Good morning, everyone. Thank you, Megan, for that introduction. So I am going to talk today, I'm going to give a little bit of background on the project that we've been working on for the past couple of years at Earth Lab. And then I'm going to talk about some of the ways that we've been using LANDFIRE in this project. So the project is called Risky Fire. And it is kind of a unique collaboration between Earth Lab, which is housed at Ceres at the University of Colorado, Boulder, and Southern California Edison, which is a power utility in Southern California. So why did this collaboration begin? Well, anyone who's in California knows that wildfires are increasing. The fire season has been longer. It's getting more intense. We're seeing other work in Earth Lab. So Earth Lab, we really focus on fire modeling. And a lot of what we've been seeing is increasing fire in what's called the wildland urban interface, or the WUI. And that's as people start moving, humans start moving into these interface spaces, there tends to be more fires in those areas. And human-caused wildfires account for about 85 to 97% of fires in the Western United States, depending on which source you look at. And the effects of fires are obviously very costly. There's firefighting expenses, there's property damage, and most notably PG&E was, it's been commonly called the first bankruptcy due to climate change, and it's probably not going to be the last. So that's what this little graph here is. And so Southern California Edison is another power utility in California, and their power lines are a fire risk, right? Down lines can ignite fires. And so what they were interested in and why this collaboration started was how they could determine where vegetation was building up around their infrastructure so that they would know where to send their crews to cut that vegetation back. And so they've been strategically investing in a number of things, especially in fire science, to reduce the impact of wildfires in their service area. Upgrading power lines, they want to bury them in critical areas, and they want to clear that vulnerable vegetation, and also do better on timing for and locations for public safety power shutoffs, or PSPS. And so our team at Ceres has worked with Southern California Edison to develop this predictive vegetation buildup index using publicly available data. And what the model produces is a quarterly heat map, and it's a predictive model. So what we're trying to do is every few months produces heat map to identify areas that are subject to significant wildfire activity based on the vegetation life cycle. So what do I mean by that? Here's the study area. Southern California is about 2/3 of the state of California. It's not a great map. I apologize for that. So when we started working on this project, I was new to fire modeling. My background is actually in geological engineering, and I usually do hydrogeologic models. So with that kind of a background, first of all, I'm looking for data. I go to USGS, right? USGS is going to have some data maybe that I can work with. And that's how I found out about LANDFIRE. So I'm a pretty relatively new user of LANDFIRE products. So I'm coming from that perspective. So to develop our model, the initial thing that we had to do was develop a spectral library with the spectral signatures for the characteristic vegetation in the study area. We didn't want to just know what the vegetation was, though. We also wanted to know where it was in its life cycle. So is it greening up? Is it browning down? That's what we wanted to capture, because we're trying to create a predictive model here. And so the method that we came upon to do that is we're using Sentinel-2 data, just because it has some features that for this project was better than Landsat. and a couple of algorithms. One is the multiple end member spectral mixture analysis, or MESMA algorithm, and then the IES algorithm is iterative end member selection. And we've just processed tons of satellite data, built up the spectral signature library for the study area. And excuse me, it's not easy to do that. It's not easy to capture browns when you're doing remote sensing or looking at satellite imagery. And so that's why we came upon these two algorithms that go pixel by pixel and can identify those different characteristic spectral signatures. But before we started that, we needed to characterize the site. None of us live in Southern California. None of us were really familiar with the study area. And so that's the first time that we used LANDFIRE products. And we used, I think, almost everything that LANDFIRE had available at that time. That was a couple of years ago, just to kind of get an idea of what areas were more critical, what areas we might expect to see dead vegetation building up, what the natural fire regime might look like, and so on. And so LANDFIRE was very useful for that. We were going to use it. We're working on a Bayesian model right now. It's actually a random forest model, and that incorporates the spectral signature, or the spectral library that we've been creating, and a couple of other layers, such as topography, which can determine fire behavior, and some climate weather data. So we decided not to use LANDFIRE products for that part of the project, but we are going to use them again to validate our model, because there are a number of field observations in LANDFIRE products, which we do not have in our models. So this is just that green up, brown down, that life cycle of a plant, right? In the spring, they're becoming more green, and then it becomes a degrading function as they start to brown down. And as they brown down, we were trying to capture at what point do they become a fire risk, not only with their life cycle, but in a sufficient quantity. So that's just kind of a simple, and this is just some eye candy. What do I mean by looking at the spectral signatures? And this is just Sentinel-2 satellite images and showing the different spectral signatures captured. And that's just a graph of those. So this is our model development workflow here. So like I said, the first thing we did was the site and fire behavior analysis, and we did that with LANDFIRE products. Then we started building those satellite layers, building the spectral library, and then we had, dynamic layers for Southern California Edison to look at. And then to build the Bayesian model, we added topography, climate data to build a random forest model. And then by combining all that, we can build hopefully, we haven't gotten to this part yet, 3-month predictive gridded fire potential model for vegetation. And so this is what Southern California Edison asked us to do, so that they, again, know where to send their crews out. They have a pretty big service area, and they, and their resources are what they are. So they wanted to know, where is vegetation buildup a huge problem? Where do we need to send our crews out? Are there places where we need to bury power lines? It's very expensive to do that, so they can't just do it everywhere. There's like the Mojave Desert is a big part of their service area. That's not a huge fire risk area for the most part, but parts along the coast, the coastline, are certainly bigger risk areas for fire. Okay, so next steps, and this is just our intro, but we still have to complete the spectral library, complete and validate the random forest model, and then integrate the validated model into the sponsor's existing framework, which happens to be in ArcGIS. So that's just a little bit about the project. And then how did we use LANDFIRE products? Well, as I said in the beginning, we used it, first of all, for site characterization. LANDFIRE provides several vegetation classifications, like existing vegetation type, vegetation height, density, canopy cover, and those products exist for forests too. And those data sets helped us to understand the current vegetative state in the study area. And these are just some examples that we took a look at here. And we did this all in ArcGIS, this part of the project. Also, LANDFIRE has available various fuel models and fuel type data sets, and we took a look at those too. We needed to understand the fire regimes, historical fire occurrences, and so on. And this is just another layer that we use. Please excuse my ridiculous map colors. we had a team member at that time that had difficulty distinguishing colors, so I made a really colorful map for this, and that's why. This is LANDFIRE's Vegetation Condition Class, or VCC, and we use that to assess the degree of departure from the natural fire regime, because that can tell us where there's disturbed areas, right? Those disturbed areas, those could indicate changes in vegetation structure and fuel conditions. So it's not just about the vegetation, but it's also about the structure of the vegetation, and so forth. And so that allowed us to assess areas with elevated fire risk due to unnatural fuel buildups, and so that we could prioritize areas that were at the greatest risk for fuel accumulation. We took a look at the disturbance data too. So LANDFIRE has two disturbance products. One is for fire disturbance and one is human disturbance. They're slightly different, but really similar, as you can see from these two images. And so looking at these two data sets gave us some ideas about where fresh or regenerating fuels might be posing a heightened fire risk as it kind of matures and accumulates, and where there's disturbed areas. Okay, so another use case that we use this for, let's see, we're going to use this. We haven't used it yet, but this is the plan, is to use it to validate our model output. And one of the ways in which we can do that is by just a simple overlay with ArcGIS or GIS and LANDFIRE data layers. So we can visually inspect these, right? And just look for any patterns, see how they compare. If there's big differences or if there's mismatches, then we can go to the random forest model and we can tune the hyperparameters. And I don't know if any of you have ever worked with random forest models. They can be a little bit fiddly. And a lot of times it comes down to adjusting these hyperparameters to kind of get to a model solution that seems to be the most reasonable, right? All models are wrong, but we try to do the best that we can to get our models to produce as close to real world output as we can. And so this is kind of during the modeling or during the random forest classifier process that we're going to be doing this. And this is more of just like a visual thing to guide that. And then we can also, what we also plan to do is to validate our model using LANDFIRE Products to see how our output is comparing to what is, established LANDFIRE data sets, excuse me. And one of the data sets that we're going to use for that is the Fuel Characteristic Classification System, or FCCS. And that will help us to assess how well the model is capturing areas with high fuel loads. And then VCC, again, there's my colorful map again. So we can use that. Fire regime groups, which I'm glad are separate again. They were briefly for a while kind of bundled in with the biophysical settings. Fire return interval, and just kind of calibrate to see how our model is working with those, see if our model hotspots align, and they should. We'll look again at the disturbance data, compare buildup of dead fuels in the model with areas of past disturbance and see how those are correlating. because areas with high fire disturbance have altered vegetation patterns that could lead to dead fuel accumulations. And the human disturbance data will show us if land use changes have contributed or are contributing to dead fuel accumulation in areas that the model identifies as a hotspot for fire risk. And a lot of that is visual, but we can also do some statistical validation on the random forest model using, for example, what's called a confusion matrix. And a confusion matrix, the output is 4 different things. It's either a true positive, a false negative, or a true negative. And we can run these confusion matrices. It's just, you do it in Python, you do it with scikit-learn. And what those matrices will tell us is, well, various different things. There's different metrics. There's metrics for accuracy, for precision, for recall or sensitivity, model sensitivity, and then the F1 score, which I'm sure everyone here is familiar with. And so those different metrics, we can run those on both our output, our model output, and on the LANDFIRE products and see how those compare. This is just details about how you perform a confusion matrix. Right, so we'll select, when we haven't done this part yet, so I'm not sure which we'll do, but we'll select a LANDFIRE product or maybe products to serve as the ground truth. And then we'll match predictions with the ground truth for each pixel or area. And the model prediction, so dead fuel buildup will be a predicted positive, no buildup will be a predicted negative. And then for LANDFIRE data, dead fuel buildup will be an actual positive, or no buildup will be an actual negative. And then we'll count those occurrences and compare them between the two, or 2 or more data sets, depending on how many we use. Okay, so what has been my experience using LANDFIRE products as a pretty new user? Some of the strengths that I found, I feel that LANDFIRE provides a really wide range of data sets. It was a little confusing for me at first as I was new to this space to understand like the difference between the vegetation layers and fuel layers. But I think once I got a handle on that, we really used a lot of different LANDFIRE products for that initial site characterization and to kind of understand the dynamics of fire and vegetation and what was happening in our study area. LANDFIRE products, they're standardized, right? Products are developed using standardized methodologies, and that ensures consistency and reliability for comparative studies, which is what we're doing. So that's pretty important for this project. Provides critical information to assess fire risk, planning for fire management strategies, understanding fire behavior and different ecosystems. Just like I said, a wide range of things are available. And everything's available to the public. So that promotes transparency and collaboration among researchers, land managers, policymakers, and any other interested partners. Some of the weaknesses that I found, temporal limitations. Some of the products might not capture rapid changes in vegetation or fire behavior. There's not real-time data. It was, when I first started using it, updated about every 2 years, I believe, and now it's updated yearly. Is that correct? Got it. Okay. So when I first started using it, it wasn't maybe the most up-to-date information. That wasn't critical for this project at that point. I was just trying to understand the study area, so that was fine. But for building this project that Southern California Edison wants, they want real-time or near real-time and a part predictive. So that was one of the limitations that we had. And the other was the resolution constraints. We're using Sentinel-2 because they have 10-meter and 20-meter bands, which Landsat does not have. LANDFIRE products are based on Landsat, so they're 30-meter resolution like Landsat is. And that spatial resolution is just not the best for a smaller study area like we have. That's really meant for, CONUS wide or larger products. There are some data gaps. Some areas might have limited data coverage or outdated information, so that can affect reliability somewhat. And then interpretation challenges. And that was, as I said, when I first started working with LANDFIRE, just coming from a different background and not really being familiar with this kind of modeling, I really needed to, it took me quite a while to get up to speed. And I really needed to have a solid understanding of some of the ecological principles in order to be able to interpret and use some of the LANDFIRE products. So just a couple of suggestions that I have: better temporal and spatial resolution. That would allow for localized site-specific management, particularly for that urban wildland interface, or that WUI where fires are increasing. Integrating satellite observations to update fuel conditions. And I just, what I mean by that is just more frequently. I don't even know if that's possible. That might not be possible. A side project that I've been working on is with the Sichongo Climate Center. And with that project, that's a tribal-based project. And a lot of the decision makers in that space don't necessarily have a background in science. And so it occurs to me that making story maps, very user-friendly dashboards and tutorials, I think could make LANDFIRE data more accessible to people in that space who are maybe decision makers or land managers, or even the general public who are interested in how our climate is changing, how fire regimes are changing, what places are at risk, but they don't necessarily know how to use what's available right now. And then I'd love to see some expanded collaborations with local organizations, universities, citizen scientists, tribal decision makers. And I think that, that could just add more data to LANDFIRE, could provide for some more ground truthing and so forth. So just some ideas I had as a new user. Okay, any questions?
Thanks, Lily. I really appreciated those last couple slides. It's so great to hear from a newish LANDFIRE user. I'm going to scroll up in my chat to Henry's question. We can just start there. And then, I don't know, Henry, do you want me to ask it, or do you want to take yourself off mute? No pressure. If you don't take yourself off mute, I'll just read it. All right. So is the MESMA, I don't know if it's IES nationwide? You described two data, or
So MESMAs and IES are just algorithms, and they're open source. Anyone can use them.
Okay.
Right now they're kind of integrated with QGIS. So it's easier to use it in Q. There is a standalone package, but it hasn't been updated for some years. So it's a bit out of date. We are at Earth Lab, since we're using it for this project and some other projects. We are trying to make a standalone Python library for MESMA. We're not quite there yet.
Great. He also had a comment like the green up, brown down work. This is good. Did you review the LANDFIRE MoD-FIS seasonal products or other efforts such as Fuelcast or Grasscast? Are you aware of those?
Yes, we did use Fuelcast. We didn't use MoD-FIS. And I don't remember why now. It might not have been available at that time. It was kind of during the pandemic that I started working on this. But yeah, MoD-FIS would have been good to use for sure. I was taking a look at that yesterday.
Great.
And Fuelcast was useful. Fuelcast, though, being limited to rangeland. And we do have some rangeland, but it's not really the dominant ecosystem in the study area. So we found that for this particular project to be somewhat less useful than LANDFIRE products.
Great. Jim asked, did you compare your products against other data sets such as California fire hazard zones? Even if not directly comparable, it is is it instructive to see where they coincide or conflict?
Well, we haven't produced our products yet, so but that's a
Oh,
great suggestion. I'll do that. Thank you.
so Jordan works with tribal landholders in Southern California. I'm interested in sharing more information about the tribal product or project you mentioned.
That'd be great. I'm gonna put up my, let's see, here's how you reach me. I'm a tribal college graduate and I work often in tribal spaces, so happy to collaborate on any tribal initiatives.
Yeah, a couple questions first, and we'll comment first. One of my favorite things about Landfire is being able to do what you mentioned, which is just learn about an area, just get my bearings and see what's there. I think that's what's fun for one thing, not to mention really useful. So I just wanted to kind of amplify that. Then a couple questions. You mentioned, I believe, the possibility of using plot data from Landfire, and I think I know what you mean there, but I wondered if you could elaborate on that if I did hear that properly, possibly for other users, and we can chime in too if that's helpful. But I was curious about your thoughts there.
I'm sorry, what data?
Um, Plot data or reference events data, we have databases that have events that users and federal agencies have submitted, and it sounded like you were thinking of using that to as part of your modeling
We
process.
we might or we might not. So Earth Lab where I work, like I said, we focus on fire modeling, and we have a few products like that our lab has created. We might use our own products for that part,
Mhm.
although I am aware
Mhm.
of the events database, and we might take a look at that too. I'm not sure yet.
I would be really curious as to how did you go about learning about Landfire data sets as a new user, and you offered up some really good ideas for how we might accelerate that learning curve. I was curious, how did you go about learning about the data sets, and if you had any additional comments on how we could help new users better understand which data sets to use and what they mean and that sort of thing.
Sure. Well, like I said, my background is geological engineering. And so when I look for, when I'm looking for data, I go to USGS. That was just my instinct. And that's how I found Landfire. Um, and it was, I feel like I love USGS data. It's not always easy to use it or find it. And I think those kind of maybe like a interactive dashboard, story maps, more storytelling about what Landfire offers, geared towards decision makers, land managers, people like that who may not necessarily have a background in science, but they find themselves in those type of roles where they need to make these decisions, and they're not always sure how. And so a lot of times they'll look for a consultant, and they'll have that consultant interpret things for them or tell them how to use it, or just simply make them data products. So I think something a little more direct for people to interact with.
Hi, Lily. First, thanks for being on and for the suggestions about communication. That's always a difficult part of these jobs. So, any specific recommendations you have, we'd like to hear them. I did have a comment or a question about your use of vegetation departure and vegetation condition class,
Okay.
and maybe it could be a concern, but the way that Landfire calculates it may not have been the way that you should have used it. So I might
Okay.
suggest that you talk to us, the Landfire team,
Okay.
myself, or Randy, or anybody on the team to take a look at it, because the way we summarize departure and condition class may not be representing your landscapes precisely. Let's put it that way.
Got it.
We use big areas to summarize conditions.
Sure.
And they may be something that we'll talk to you about how to recalculate condition class just for your landscape.
Got it. Okay,
And
great. Well, that
instead of
would be very
using
helpful. We
maybe,
haven't done that yet,
yeah,
but when
okay.
we get to that part, that
Yeah.
would be super helpful.
Yeah,
So thank
definitely
you.
reach out because it can be
Okay.
a bit of a bad path to use what LANDFIRE provides as delivered on the website for smaller
Okay.
land and for pieces of states and things like that.
Sure.
So,
Sure.
well,
Yeah.
thanks again, Lily, for the information. It was very useful.
Well, thank you for the offer. Appreciate that.
Looks like Angela's asking, are you considering using any Cal Fire FRAP data since it is more tailored to California specifics?
Sure. Yeah, we've used CalFire. They're even more difficult to use, I think, than they're not user friendly at all. But we have used CalFire.
By the way, Lily, Randy here again. I'll put a link in the chat if you haven't. I wonder if you've used the Python package for importing LANDFIRE data into your Python environment.
I did not know there was one.
We'll put it in the chat and share it out for folks because it might be useful. Also, I'm going to ask the LANDFIRE community that's on the call today, if you had any advice on which fuels data might be best for Lilly and others to look at when doing something like this. Like Lilly, you mentioned a couple different LANDFIRE fuels data sets, but I would love to hear Tobin or others maybe expand on, if you have any opinions on which data sets might be best for, using for use of comparison in this context.
I wanted to clarify one of them.
And Inga, do you want to introduce yourself for those on the call that aren't familiar
Sure.
with you? Yeah.
My name's Inga LaPuma. I'm a LANDFIRE program lead with the Forest Service. And I'm very well versed in explaining what our layers mean, right? To new users especially. And so I did want to make a few clarifications. But I also want to mention that I think it's confusing. There's a lot going on, And so I really do appreciate your suggestions, Lily, about how we can better kind of just demonstrate what do these things actually mean and what do they represent. And so you mentioned that you used fuel vegetation height. So I'm assuming like FVH was like the acronym for that. So the one thing that I wanted to mention is that FVH and FVC are really sort of they're pre-disturbance inputs.
Okay.
So where there's disturbance, you're getting pre-disturbance FVC and FVH. So those inputs, if you see, these are all the inputs that we use in the LANDFIRE total fuel change tool to account for disturbance. And then you get your outputs with canopy height, cover, canopy bulk density, and FCCS and so forth. So these are the ones that are representing kind of that post-disturbance situation. Yeah. And then the other clarification I wanted to make was with the HDIST and the reason that you were seeing that things are pretty much similar is that the HDIST is essentially 10 years of annual disturbance kind of mushed together, right? With the latest ones overlying the top, overlying the bottom ones, right? Like the older ones. So I just wanted to mention that, yeah, this it's pretty much the same as our normal raster disturbance layers. It's just 10 years worth of it. So so I wanted to clarify that. And so yeah, I think it really does kind of show that there's work to do in our communications and I also just want to encourage folks to reach out to us if there's any vagaries and it's just not making sense. Our help desk is always available to help you interpret what you're seeing. So those are just the two clarifications I want to make, but everything else it's really cool that you're able to use so many of our layers and pull them into your model. So I'm pretty excited to see some of those outputs.
Thank you. Appreciate that.
What's the timeline of the project? Like, when do you expect to have those results that you were talking about?
We're hoping by the end of the year. We're pretty far along in the spectral library. It's just about done. And the code is pretty much done for the random forest model. And then it's just running it. So
I'll jump in. Lily, really well done. Where are you going to go next? What's your future? What big ideas, big projects are you thinking, and how might LANDFIRE play into those?
Well, right now, like I said, I'm working on a lot of tribal projects. Where my lab has a sister lab, as I call them, called ESOL, and we're both under series, and we're working on some grants with the EPA and National Science Foundation for some tribal projects, some really big ones. We have a lot of partnerships. We have a lot of tribal members that are working in these labs. And yeah, those labs have really made a conscious effort to outreach in tribal communities. My husband and I are in Colorado because of those initiatives. We came from, attending and teaching at tribal college in South Dakota to Colorado, working at a big university. So we really still focus on what we can do in Indian country. That's really, my husband is the tribal data scientist for ESOL Lab, and what he likes to say is that Indian country got left behind in the data science revolution. And so we're hoping that, that gap can be filled. And so what people back home are really interested in is climate resiliency and data sovereignty. And so that's kind of the spaces that we've been working in, and we hope to really expand what we're doing in those spaces. And that will require an enormous amount of work, but hopefully we get there, making a lot of partnerships and working with different people and so on. So
Yeah, thank you so much, Lee. I love it. And be just excited to work with you.
LANDFIRE definitely has a place there.
Well, yeah, we've done a bunch with the tribes and relative to data sovereignty and trying to, respect and, work with those data.
Yes, absolutely.
And I would love for us to figure out how we could even do more. Just because when you take 500 plus tribes, it's a challenge to work with everybody. And we've got some good things that have happened, working with like BOFARP and the continuous forestry inventory that, they have through BIA. That's been huge, as you know, and can appreciate, just like you said, data is data and you got to try to find it and, leverage it. And so trying to figure out how do we work with that and then maintain, any sensitivity associated with it is definitely high on our radar. So
I can say that USGS has been doing great on that, at least in South Dakota, just the area that I'm familiar with. I know my husband spoke with the people in USGS employees in South Dakota about removing LiDAR data that was, covering the reservation, and some elders had asked that data be removed, and it was immediately removed and no problem at all. So
what I would love to do though is have you help us figure out how we can leverage the good parts of LiDAR and then peel out the sensitive parts. Because as you know, that will leave gaps. And when we think about height and understory, oh my gosh, LiDAR is an amazing, amazing data set. But I realize that there's sensitivities associated with it. So like I often tell folks, I'll take the Department of Defense as a good example. They've got some amazing goodies that I would love to get our hands on.
I have no idea, but I'm sure.
If there was a way that we could use some of the goodies while still being sensitive, I would love to try to figure out what that solution looks like.
I might put you in touch with my husband. He works more on the data sovereignty side of things than I do, but that's a conversation, and that's a great conversation to have.
Sweet. Thank you so much, Lilly.